Dingleberries?
Yeah, okay.
Always dingleberries.
Okay.
If you're interested in performance engines and particularly sort of turbo engines and things like that, you'll have probably heard the term forging your engine, which in all honesty is a term I hate with a passion. It doesn't really explain what goes into the engine to say that it's forged, and I think it's a common misconception that that simply means adding forged rods and pistons. That's what the term's often used for, and engines are never ever that simple. There's also a lot to determine what a forged part is and what isn't. So let's get that bit out of the way first. Forging is a process of producing parts, in this case often aluminium or steel, where you use pressure as well as heat, and that differs from casting, which just uses heat. So forging basically means that you have a far stronger metal structure, which obviously when you're producing engine components that are being pushed to the limit is a very, very good thing. However, to say that a part's forged or that your engine's been forged is often meaning aftermarket forged components. And to say that an engine's fully forged from factory isn't incorrect. In fact, it's quite common really to forge engine components. Take the S55 for example, that has forged rods and pistons. So if we take a look at an OE forged component, in this case, various components put together, the piston is actually in this case I believe a Marler piston, which we'll go into in a moment. It's pretty commonplace for OE components or OE pistons to not have a skirt coating. In this case they do. Skirt coating technology and coating technology as a whole has come on quite a way, especially in the last 10 years or so, and it is becoming more and more commonplace for an OE component to have coatings on it. That also applies to bearings, which we'll cover in another video. Let's have a look at some aftermarket forged pistons. We've got three here in front of me. This is a JE piston, this is a CP piston, and this is a Marler Motorsport. So these are for different applications, and actually all of these are normally aspirated, but often where the advantage of forging an engine comes is the strength that you get, which when you're boosted means that you can run more boost and essentially make more power reliably. So there are quite a few different elements to piston design which often isn't understood. I'd say probably your first thing you're going to be looking at when you're buying a piston is compression ratio and bore diameter. Different manufacturers will offer different compression ratios and bore diameters, and it's pretty commonplace, certainly a lot that we do, to go 0.5 millimeter over size or more. This is an S14 piston, which actually is going quite a long way over bore to really take the capacity up. Putting a forged aftermarket piston or any piston in a bore that's already worn it's not a no-no, but you really need to measure up that bore for wear, both in terms of whether it's got scoring on it and actually the sizing of it. What you'll find with a long stroke engine is that because the piston's getting pushed sideways at the bottom of the stroke, the bore will be bigger at the bottom than the top, and there is just no point running a nice set of pistons that have a very specific clearance that they're designed for in a bore that isn't consistent, because essentially it's just going to wear out faster, you won't get proper sealing. Any inconsistency in an engine just is a recipe for not being optimal. Your next element to consider is compression ratio. So that is quite literally how much the engine is squashing the air that's pulled into it. And if you have a higher compression ratio, it means that you've got higher cylinder pressures, which is good in a normally aspirated engine because that makes more power. However, if you're turbocharged or supercharged, you may well be looking to drop your compression ratio to safely run more boost. If you have too much compression and too much boost, you'll run into detonation issues, which is the absolute killer of any performance engine. So talk to your engine builder, especially if it's us, about that before you start ordering components. It is critical to cater your piston choice to your use. So as well as the compression ratio that the piston gives you, there's actually quite a lot to the design of the top of the piston, the crown. Not only have you got cutouts for valves, which depending on the depth of those, you can run different camshafts with sufficient clearance, which is something we will definitely go into in another video, otherwise I'll be here all day. You've also got a band around the outside. This is known as a Squish Band, which is really important for an efficient combustion. It helps essentially push the turbulence as the piston comes up and the sort of general combustion area to the middle, which is really, really important for a performance engine. Next, you've really got to look at the skirt. So skirt design is a huge part of the stability of the piston when it's in the bore. It's exactly what keeps that flat and stops it moving around like this. If you've got movement there when you've taken an engine apart, it could well be normal. There is a certain amount of movement, but under actual operating conditions, that is critical. So a small skirt is good because it's better for reducing friction. So as you'll see on this JE piston, it's actually got a smaller skirt on the non-thrust side of the piston. So it needs a little bit less stability on this side. So less metal there means you've got less friction of it running up and down the bore, and less friction means less losses, and that means more power. However, if you had a heavily turbocharged engine, you'd want more skirt there because of that stability. So it's more common to see a forced induction engine having potentially even a full skirt which runs all the way around, and it really holds that piston solid as it's going up and down the bore, and also does add strength as a bit of a byproduct. That's really all there is to it. It does essentially mean that when you're choosing a piston, no matter what compression ratio, there's a lot more to it than just that. You've got to consider the other design properties of that piston and how suitable it is for your use. Something else you might notice about these pistons in front of me is that they're all different colours, and that is not because they're different materials, it's due to the coatings on them. So underneath any coating on a forged piston, you'll probably find your raw forged aluminium. This may differ slightly between them where they're different material compounds, but at the end of the day, forged aluminium is going to be roughly that colour. If we look at these JEs, the coatings on this, these are relatively simple. They've got a coated skirt, which is a bit like a non-stick frying pan. It's a Teflon coating. That reduces friction up and down the bore, which, as we've already said, less friction means less losses, which means more power. That's a nice simple one. All of these have got coated skirts. You can see on these Marler pistons. It's a bit less easy to see on these because they're a similar colour to the coating underneath. But it just helps with reducing bore wear and reducing friction. These CPs also got it all the way around on these, rather than, for example, these JEs, you've actually got a small cutout in them for measuring, and also they haven't coated where it's not needed. So a slight difference in that. If we have another look at these CPs, you'll see they've got a gold coloured sort of bronzy crown to them. This is essentially a coating that's designed to be a thermal barrier, so they're under extreme conditions. Generally that would be turbo and things like that, but it just shields the material underneath against that heat and keeps the heat where you want it, which is in the combustion chamber, and not going down through all the components. So that's that one there. And then on this Marler piston, you've actually got a coating all over it, which for any people watching with an S54, the OE spec Marler pistons actually have a very similar coating on them. So that's graphite, or a graphite type coating, which basically helps with the piston material in both of these ways. And then Marler have also topped it up with this coated skirt. Another little detail on these Marler pistons is they've got a hard anodized top ring groove. That's a feature you don't often see in an aftermarket piston, and it's where Marler are a very big OE as well as an aftermarket supplier. That helps stop the top ring binding in there under extreme conditions, and well, if you're going to get a Marler piston, that's a really nice feature that you're going to get. We've discussed that a forged material is stronger and more resilient, and it would maybe be easy to think that that purely means that that's better for turbo because you've got outright strength, but there is a lot more to it. If you've got a forged material that is stronger, you can use less of it, so you can actually produce a far lighter piston that's forged than you could if it was a cast material that needs more to it to be strong. So you've got two ways of optimizing these pistons. a lightweight forged piston for normally aspirated use with as little material as possible but enough strength, or a heavier piston for turbo use, which is purely about strength and has plenty of material in it, and that material being forged means you've got the strongest piston possible. The next component you might consider as part of your forged build is your conrods. So this is an aftermarket set of forged conrods, and this, believe it or not, is an OE forged conrod, and you'll see they're quite different. So the fact that that is forged does not mean that it's strong enough to handle 1,000 horsepower. We've kind of covered that already. What you'll see is a very different design of rod that happens to also be forged, and that's where the strength comes from. So this is an N54 rod, still attached to the piston. You'll see it's got an I-beam design, which means it's scalloped at the sides rather than the ends. This particular rod and piston came out of an N54 that we've since done a full build on. The owner of it was looking for 800 horsepower or more, and despite being a forged rod and being an engine that's known for massive strength, it just wasn't going to be enough. And by looking at the differences between this rod and an aftermarket rod, you can really see the advantage of aftermarket rods are as much in their design as it is the fact that they're made from a forged material. And this is an aftermarket rod. This is an SP Components rod. We use these in a lot of builds we do, whether it's S54, S50. These particular ones are for an M50 stroker that we're building for turbo use. As you can see, there is a massive difference in where the material is on the rod, as well as how much of it there is. These will be very much optimized for strength. And with rods, it's a little bit less about what it's being used for, as it is about strength. Normally aspirated high revving builds will place a lot of strain on the rod, so it has to be strong, whereas a turbo build needs outright strength because of the cylinder pressures. And with rods, the same rule vaguely applies to both, and these SP rods are lovely. This standard rod is I-beam, these are H-beam. That refers to where this flat edge is, where the material has been taken out. So you can see these have been optimised by reducing material down the sides. These have got it down the front and back of the rod. The width of the material up here is really where you're adding a lot of strength, and there's also various other processes of an aftermarket forged rod that really set it apart from a standard one. One of those being essentially the tolerances it's made to. You'll find if you weigh a set of, say, 6 of these, they'll all be perhaps within half a gram of each other, whereas a standard rod might be within 3 or 4 grams of each other. Engine balance is extremely important and is something that relates to the pistons and rods together, because they're all moving around inside the engine, as well as the crankshaft, which we'll get to in another video. Another element to look for when you're choosing a forged rod is the fasteners used. So these particular ones use ARP bolts, which is pretty much the industry standard, and an element of manufacturing is that they'll have the rod bolts fitted and either torqued or stretched to spec when they hone out this. And that means that you have a perfectly round bore within the rod with the fastener attached and to a repeatable spec. The terrifying thing out there that we often see is the fact you can buy a rod without bolts and then choose which bolts you want, which means that has been, honed and measured and specified with God knows what bolt, and then you're just buying any old bolt and putting it in there, and really you're hoping for the best. Different bolts will have different fastening strengths and different properties, and that will affect how round this is. It will go oval if they're too tight or too loose, and really it's not repeatable and just a load of nonsense. Whereas these rods have got ARP fasteners, you'll often find with a standard rod that you have a far cheaper fastener. That is because BMW are making their engines to a cost. So these particular ones and a lot of the newer BMWs are a stretch bolt, which means you have to do them up to a certain angle, and it essentially stretches out the fastener to a degree that's somewhat repeatable. However, it's never ever going to be as repeatable as the production processes used for these. Another element of the production process that you may well notice is that these rods are made in one piece, bored and honed, and then they are fractured. So they actually freeze this rod, fracture it, and you get a perfect join between the two halves. That means that when that's clamped together, the two halves meet. But that means that you're boring and honing it without the bolts in, and that's different to these, because these will be made essentially as one, but then they're split, they're machined for dowels, then they're fastened, and then they're finished. And that is far, far more repeatable, because that is a situation this rod will end up in again within the engine when you're building it up. So it is the same, whereas that has been made and then altered, and that makes a huge difference in repeatability and tolerancing. Next time we'll be covering engine bearings and also balancing your engine. If you enjoyed this video, please hit like below, and also our statistics show that a lot of you haven't subscribed, so please do that. It all helps us to produce better videos in future. Speaking of better videos, if you've got any comments or questions about what we've talked about, or there's anything you want to see in the future, please just comment below. We always read through all of the comments and make sure we reply, and it also affects what videos we make in future. I'll see you next time.